Something is decaying exponentially when we are repeatedly multiplying our value by some number between 0 and 1, or we say that it's decaying by a percentage. It's decreasing by some percent. Two ways that we write our exponential decay functions. One, using the decay factor, which is going to be a number that we're calling b, and it has to be between 0 and 1. That way it's going down in value every time we multiply by this amount. The other method here is using our value r, which is our percent decrease, in the decimal format. And looking at these equations on the left, you should think that they look a little similar to our percent growth equations that we had. A equal to a naught times b to the t power. It's the same formula, it's just instead of b being greater than 1, it's between 0 and 1. And then for our percentage decrease formula here, we have a equal to a naught, or a0, times 1 minus r raised to the t power. And we're using 1 minus r for this because we are decreasing, so we are taking away our rate, essentially, from the 1. So now let's work through an example with exponential decay. We have here that plutonium-243 has a half-life of 5 hours, and you begin with a sample of 250 milligrams. And I want to write an equation that will model the amount of this plutonium-243 as a function of the number of hours that have gone by. So let's think through our definition of half-life and what this means. Half-life means that when I started with 250 milligrams, after that time period of the half-life, so in this case it's 5 hours, we have half as much. So I had 250, and now I need to multiply this by 1/2 to get half the amount, which gives me 125. Another 5 hours go by, and we have half of that amount again. So I would take 125 and multiply that by 1/2. This means that we are repeatedly multiplying by 1/2 every time 5 hours go by. So our decay factor, b, is equal to 1/2, but we need to remember that this is for a 5-hour time period. We also know we started with 250 milligrams. So our initial amount, A0, is equal to 250. So now let's get started in writing our equation here. We have that our amount A is equal to 250 times 1/2, and then I want to raise this to the number of hours that have gone by, which I'm calling h. However, h is for 1 hour, while our growth factor b here of 1/2 is for 5 hours. So I need to think about how 1 hour is 1/5 of the 5-hour time period. So that means that my 1/2 in my equation needs to be raised to the 1/5 power. And then the h gets multiplied by that. because I only want 1/5 of my time period to have gone by for when I put in 1 hour for h, and so on. So now I can rewrite this equation to make it look a little bit better here. This is going to be a equal to 250 to the 1/2, or times 1/2, raised to the h over 5 exponent. So now, in our next one, we're asked how much plutonium-243 is left after 12 hours. Well, that means I need to replace h with 12. So I am going to get the equation A is equal to 250 times 1/2 to the 12 over 5. And now this we can evaluate in our calculators. Most of the time with your calculators, to get this to evaluate correctly, you are going to need to put parentheses around this exponent. Otherwise, it's not going to include all of that in the exponent. So now, when we put this in, you should get about 47.37 milligrams as our final answer.